In this tutorial, I want to spend a little bit of time talking about coupling and what that means to your Java application. When one class becomes dependent on another, they're said to be coupled. Changes in one class often result in a change in the other. We need some sort of coupling in an application, but we need to also try and reduce it as much as possible, because applications and systems with a lot of coupling become very brittle. They also become incredibly hard to test, because generally you need to test or unit test one class in isolation from another one. If we open up the pre-Spring Sample1 project and we go into the source main Java folder, we'll see there's a client class. Let's open that up. And what we see is a pretty basic little application. What it does is it prints a message or a default message, and it uses the print message service to do that. Within here, with our main method, we create a new instance of the message printer service, and then we call the print message method on the service. So let's have a look inside the message printer service. Just right click open declaration. If we see at the top here, we've got an attribute here called service, and we've got wired in a basic message of the day implementation. So we've got a new instance of that being created and assigned to the service attribute. Now if we look at this closely, we've got coupling going on here. What I mean by that is that we're creating a new instance of this basic message of the day implementation and assigning it to the service attribute. So they're tightly coupled. What we're looking for is loose coupling. In other words, if I wanted to use a different implementation, it should be easy just to point this service attribute to a different implementation instance. At the moment we can't do this, it's hardwired. We actually need to change the code, recompile it and retest it. The same thing's also going on in the client. In the main method here, we create a new instance of the message printer service and assign it to this local variable of a message printer, and then we call the print message on it. The fact that we're actually creating a new instance here is actually binding or coupling. Now some coupling is okay. If you think about this is actually some sort of service class. It's actually performing a service. And if you think of service-orientated architecture, that's exactly what we need. We just need to be able to decouple these things so that if we wanted to use a different strategy, for example, we can. If we go over to a domain model and we open up the model package here, you see basically a basic customer and order entities. So a customer can have many orders, and an order can belong to one customer. Again, this is a form of coupling, but because this is a business relationship, and business relationships tend to be more static, in other words, they're not subject to a lot of change, this type of coupling is okay. Going back to the message printer service, this is a kind of architectural infrastructure type class. It's not representing the actual modelling of the business. It's actually performing some sort of architectural strategy or technical strategy for our application. These things tend to be more subject to change. So it's quite important that these types of relationships are actually loosely coupled. Whereas when you're modelling business objects or business entities, it's okay to have coupling there. What I'm trying to get to is that Spring uses this concept of decoupling the architectural objects as its foundation, and it uses a concept called dependency injection to achieve that. On the other hand, Spring wouldn't be used to model these types of relationships within business models or domain models. So in the next tutorial, we're going to be looking at taking this example, particularly the architectural type classes or service classes, and seeing how we can use a technique to actually decouple them by programming to interfaces.